10.0. That is the number, not feet, not miles, not degrees of temperature. 10.0 microradians, which is a unit almost nobody outside of geophysics has ever heard spoken out loud. Here's what it means. Take a flat surface as long as an American football field. Now lift one end of it by the thickness of a credit card. That tilt, that almost imaginary change in the angle of the ground, is 10 microradians. If you had been standing on that ground while it happened, you would have felt nothing. No shaking, no sound, no warning of any kind that your senses could pick up. And that number is exactly how scientists knew that one of the most watched volcanoes on Earth was about to open up again. Yesterday afternoon, it did. At around 11:20 in the morning, Hawaii Standard Time, on August 12th, cameras pointed at the floor of Halemaʻumaʻu crater caught something small. A low dome of lava, swelling at the north vent, spilling over the edge. It lasted a few moments. Then a second overflow came at 11:35 and ran for roughly 4 minutes before quitting again. Small, almost quiet, the kind of thing that could easily go nowhere. The Hawaiian Volcano Observatory did not treat it as nothing. Within hours, they raised Kilauea's alert level from advisory to watch and pushed the Aviation Color Code from yellow to orange, which is the signal that tells pilots to start paying attention to the sky above this mountain. Then, at 3:45 in the afternoon, the whole thing changed character. Episode 53 of the ongoing Halemaʻumaʻu eruption began. Lava fountaining from the north vent. The first measurement came in at 80 to 100 feet tall, and observatory scientists said the fountain would reach its maximum height within 1 to 2 hours. They were right about that too. By 4:15, the fountain had blown past 250 feet. 20-some minutes later, it was near 400, and a plume of gas and ash was climbing to roughly 16,000 feet above sea level. At 10 minutes past 5 in the evening, the observatory reported the peak. 500 feet of liquid rock standing up out of the crater floor and holding there, with a plume above it that had climbed past 18,000 feet. 500 feet is just under the height of the Washington Monument. Picture that entire monument, and now picture it made of molten stone, roaring, throwing off glass, and rebuilt continuously from below at a rate fast enough to keep it standing. That is what was happening on a Wednesday evening in Hawaii while most of the mainland was finishing dinner. So in this video, I want to walk you through all of it. What actually happened hour by hour, why episode 53 is part of something that has never been recorded in Hawaiian history, how a tilt the width of a credit card told scientists this was coming, and the one detail in that forecast that did not go the way people are saying it did online, whether any of this threatens anyone, and the open scientific question sitting underneath all of it, which is whether these fountains are about to start getting dramatically taller. If you want the follow-up when episode 54 begins, and it will begin, subscribe now, because this eruption does not announce itself on a schedule anybody controls. Let's start with what is confirmed. Everything you just heard is confined to one place. All eruptive vents, all lava flows. Every drop of it sits inside Halemaʻumaʻu crater within Hawaiʻi Volcanoes National Park in an area that has been closed to the public since late 2007. No town is being approached, no highway is being crossed, no neighborhood is on a countdown. What is leaving that crater is the plume, and that is a different story. Ground level sensors near the vents showed wind coming out of the northeast, which pushes gas and volcanic material toward the west and southwest of the summit. Higher up, above the trade wind inversion, the winds run more easterly, which means if the fountain throws material high enough, that material gets carried west instead. The National Weather Service office in Honolulu put out a special weather statement about it. Ash, Pele's hair, other lightweight tephra, potentially falling downwind of the summit. And the phrase in that statement that matters most is the one about distance. Larger particles drop close to the vent, the smaller ones ride the wind, and they can reach communities much farther away than people expect. Pele's hair deserves a sentence of its own. because it is one of the strangest things this volcano manufactures. When a fountain throws molten lava into the air, some of it gets stretched into filaments as it flies, and those filaments cool in flight into strands of volcanic glass thinner than sewing thread, golden, almost beautiful. And they are still glass. They get into gutters, into water catchment systems, onto skin, into eyes. Downwind residents on the Big Island have learned to recognize them the way people in tornado country learn to read a certain color of sky. Now, one thing about those numbers I gave you, the early readings during an episode like this get revised. In the first hour, different outlets were reporting fountain heights that did not agree with each other because measuring a moving column of incandescent rock from a distance in real time is difficult, and because there is a real difference between measuring the top of the dense fountain body and measuring the highest scattered wisp of glowing material. The observatory measures the dense body. Some historical eruptions were measured the other way. Keep that in the back of your mind, because it matters in a few minutes when we start comparing this eruption to the giants. Here is where episode 53 stops being just another pretty night in Hawaii. This eruption started on December 23rd, 2024. It has been running in pulses ever since. Fountain, stop, refill, fountain, stop, over and over. Most episodes last less than 12 hours. Most pauses run days to weeks, and some have stretched past 3 weeks. On average, across the whole sequence, an episode has arrived roughly every 11 days. Most people book a longer vacation than the gap between these eruptions. And the count is now the headline. Before this, the record for the most fountaining episodes ever recorded at Kilauea belonged to the opening phase of the Pu'u'o eruption, which started in January of 1983 and produced 47 high fountain episodes before it settled into the long, slow lava flow that most people remember it for. That phase took about 3.5 years. The current summit eruption tied that record on May 14th of this year at episode 47. It broke the record on June 1st at episode 48, and it reached 47 episodes in roughly a year and a half, which is less than half the time it took Pu'u'o to do the same thing. When the sequence hit episode 50, the deputy scientist in charge at the observatory described it as the largest number of eruption episodes seen at any Hawaiian volcanic eruption in recorded history. Not the biggest, not the most dangerous, the most episodes. A machine that keeps restarting itself. For context on the other famous ones, the 1959 Kilauea Iki eruption produced 17 high fountain episodes. The Mauna Loa eruption of 1969 and 1970 produced 12. Kilauea Iki still holds the height record, with a fountain measured at just over 1,900 feet, which is taller than One World Trade Center in New York. That monster lasted about 10 minutes. The current eruption has not matched that, but it has come closer than most people realize. Fountain heights across these 53 episodes have ranged from 130 feet at the low end to 1,770 feet at the high end. That tall one would clear the tip of the Empire State Building's antenna with room to spare. And all of this rock has to go somewhere. The cone that has been building around these vents has added roughly 150 feet to the elevation of the crater rim. A 15-story building's worth of brand new mountain assembled out of spatter in about a year and a half. Pu'u'o did something similar and built a cone over 800 feet high that was visible all the way from Hilo, and then quietly swallowed that cone back into its own vent system by the 1990s. That is the thing about Hawaiian volcanoes that never lands properly on video. You are not watching a mountain erupt. You are watching a mountain being manufactured in real time, in front of live stream cameras, on a timescale short enough for one person to watch the whole process, which brings us back to that number. 10.0 microradians. How does a tilt that small predict a 500-foot fountain? Think of a tipping bucket. Not a bucket you carry, but the kind mounted inside an old rain gauge, balanced on a pivot, with a small container on each side. Water drips in slowly, and for a long time nothing visible happens. The bucket just sits there, filling. Then it crosses a threshold, and it goes over all at once, dumping everything, snapping back to its resting position, and starting to fill again. The dripping is slow and boring. The tipping is instant and dramatic, and the whole system is completely predictable as long as you can measure how full the bucket is. Under Halemaʻumaʻu, there is a shallow magma reservoir, and it is being fed from below. As new magma pushes in, the reservoir swells, and the ground above it swells with it. Not visibly, not by an amount any person would notice standing on it, but tilt meters notice, because a tilt meter's entire purpose is to detect the ground changing its angle by amounts smaller than the eye can resolve. So the observatory watches the tilt climb, inflation, the bucket filling. And they have learned, across 52 previous rounds of this exact behavior, that when the accumulated inflation climbs back to somewhere around 8 to 10 microradians after the last episode, the system is close to going over. As of the daily update on August 11th, the tilt had recovered 10.0 microradians since episode 52 ended. The vents were glowing continuously overnight, with flames appearing at the north vent. Every ingredient that has preceded every recent episode was on the board. Then the eruption happens, and the whole thing reverses. During episode 52, the tilt meter recorded 14.4 microradians of deflation. The bucket tips. The ground settles back down as magma leaves the reservoir and goes up the pipe instead. The episode ends, often abruptly, sometimes within minutes, and almost immediately the tilt flips back to inflation and the next fill begins. The gas is what turns a filling reservoir into a 500-foot fountain. Magma at depth carries dissolved gas the way a sealed bottle carries dissolved fizz. Down deep, under pressure, that gas stays in solution and behaves itself. As magma rises through the conduit, the pressure on it drops, the gas comes out of solution into bubbles, and those bubbles expand violently as they climb. By the time the mixture reaches the surface, it is not liquid rock oozing out. It is liquid rock being pushed through a nozzle by its own expanding gas at a speed that throws it hundreds of feet into the air and holds it there for hours. That is why the fountain does not simply spurt and quit. As long as the reservoir has pressure to give and gas to release, the column stands. So, the forecast. On August 3rd, the models pointed to a window between August 7th and August 14th. Then, a stretch of deflation interrupted the refilling. The summit vents went relatively dark. The big gas flames that had been visible stopped appearing, and the observatory shifted the window to August 11th through August 14th. Then, as the tilt pattern kept evolving, the window moved again in the August 11th update to a forecast onset between Thursday, August 13th, and Monday, August 17th. The fountain started on August 12th. I want to be precise about this, because a lot of people are about to tell you that scientists nailed the date exactly, and that is not quite what happened. Episode 53 arrived about a day ahead of the most recent published window. It landed comfortably inside the earlier windows, and it landed within roughly 24 hours of the newest one, which by the standards of volcano forecasting is close to remarkable. But it was early. The observatory itself had written that the window might be adjusted if the tilt pattern changed significantly, and the volcano did what volcanoes do, which is to remind everyone that the model describes the system rather than commanding it. Here is why that honest version is more impressive rather than less. 53 times in a row, this volcano has filled, tipped, drained, and reset. That repetition is what gave scientists a testable pattern, and having a pattern that is right to within a day or two is something that would have sounded like fantasy at almost any other volcano on Earth. Almost nowhere else does anyone get to say, in public, in advance, in writing, that an eruption will begin within a specific stretch of days and then get graded on it. Have you ever watched one of these live streams while it was happening? Drop a comment and tell me where you were and what time it was for you, because these fountains have been going off at every hour of the day and night, and I would like to know how many people have caught one live without planning to. Now to the part that scientists are watching most closely, and it is not the height of this particular fountain, it is the chemistry. There is a puzzle in this eruption that has not been solved. The fountains vary wildly in height, from 130 feet up to nearly 1,800, and the variation is not random noise. It comes in cycles. The observatory has identified 3 distinct growth cycles across this eruption, where fountain heights climbed episode after episode and then dropped sharply. Episodes 5 through 16, episodes 17 through 28, episodes 29 through 43. What controls that? Several things at once, including the shape of the conduit, the thickness of the lava, and the rate at which new magma is being supplied. But scientists went looking in the rock itself for a fingerprint, and they found one. When lava fountains, some of it cools so fast in flight that it freezes the chemistry of the magma exactly as it was at the moment of eruption. Collect that tephra, analyze it, and you get a direct chemical snapshot. One of the things they measure is magnesium oxide. Higher magnesium oxide means hotter, fresher magma, less time spent sitting around cooling underground. They also measure olivine, the green mineral that is everywhere in Hawaiian lava, and the ratio of magnesium to iron inside those crystals tells the same story from a different angle. Starting around episode 29, the correlation became consistent. When fountain heights went up, magnesium oxide went up. When fountain heights crashed at episode 44, magnesium oxide dropped with them, and a new population of olivine crystals appeared, the kind that forms when magma has had time to sit and cool because less fresh material is arriving from below. Then, in episodes 46 through 48, both numbers started climbing again, which is why the observatory raised the question directly in a public article days before this episode fired. If magnesium oxide is rising and fountain heights are rising together, that may mean magma supply is picking back up and Kilauea could be entering another period of growing fountains. Episode 53's 500 feet is now a data point in that test. It is the same peak height as episode 52. It is a bit more than half of episode 51, which reached about 950 feet. So this one does not confirm a growth phase, and anyone telling you tonight that the fountains are definitely about to double is going past what the measurements support. The tephra from this episode has to be collected and analyzed before anyone knows what it says, which is a good moment to be straight with you about the whole picture. You are going to see this event packaged online tonight as Hawaii exploding. It is not. Every vent and every lava flow in episode 53 is inside a crater, inside a closed section of a national park, in an area that has been off limits to the public for close to 2 decades. This is not the summer of 2018, when the Lower East Rift Zone opened up through Leilani Estates, swallowed neighborhoods, and forced the summit to collapse in on itself. That was a different part of the volcano behaving in a fundamentally different way, and comparing the two is not dramatic, it is inaccurate. The 500-foot fountain is not a record either. It sits in the middle of this eruption's own range. The plume above 18,000 feet sounds enormous, and it is higher than the tallest peak in the lower 48 states, with about 3,500 feet to spare. But episode 48 produced a plume near 24,000 feet, and that was the standout of the cycle. So what is the real hazard here, if it is not lava reaching homes? Gas. Constantly and unglamorously, gas. In its typical range, this summit releases somewhere between 1,000 and 5,000 tons of sulfur dioxide per day. At the high end, that is roughly the weight of 800 adult elephants, pushed into the atmosphere every 24 hours, entirely invisible. That sulfur dioxide reacts in the air downwind and becomes VOG, the volcanic haze that has been part of life on the Big Island for decades, and it causes real respiratory problems for real people, especially those who already have breathing conditions. Tephra is the second hazard, and it does not stop when the fountain does. The particles that landed during previous episodes can be picked up again by wind and put back into the air days later. Fine ash and glass fibers do not care whether the eruption is currently active. The third hazard is the ground itself around the crater rim, and this is the one that gets underestimated. The tephra piling up on that rim cracks, slumps, and slides, and those slides sometimes expose material underneath that is still hot enough to be molten. Add crater wall instability, ground cracking, and rock falls that earthquakes can trigger, and you have a rim that is genuinely lethal to stand on. That closure, since 2007, is not bureaucracy. It is the reason nobody has died there. And there is a fourth item, which is aviation, and it is the reason the color code exists at all. A plume that reaches 18,000 feet is a plume that reaches into airspace, and volcanic ash and jet engines have a long and ugly history together. Orange is not a warning to the public. It is a warning to pilots and dispatchers, and it is doing quiet work every time one of these episodes fires. So what should you actually watch for now? The first thing is duration. Most episodes in this eruption have lasted less than 12 hours, and the ending tends to be abrupt rather than gradual. Episode 52 started at 10 past 7 in the evening and stopped at 36 minutes past 2 in the morning, roughly 7.5 hours, and it did not fade out, it quit. There is a real chance that by the time you are watching this, episode 53 is already over, and the crater is dark again except for glow. The second thing is the tilt. The moment the fountaining stops, watch for the switch from deflation back to inflation at the summit tilt meter. That flip has preceded every recent episode in this sequence, and it is the clearest signal that the bucket has started refilling for episode 54. When that accumulated inflation climbs back toward 8 to 10 microradians, expect a new forecast window and expect the alert level to move from advisory back to watch. The third thing is the chemistry result. Tephra from this episode will be analyzed, and the magnesium oxide value will either continue the upward trend from episodes 46 through 48, or it will not. That single number is the closest thing anyone has to a preview of whether the next fountains climb toward the tall end of this eruption's range. And if you live downwind or you are planning a trip to the Big Island, the practical version is short. Check the observatory's status before you go, because on any given night, the summit is more likely to be paused than fountaining. Watch the VOG forecast if you have asthma or any respiratory condition. Do not handle Pele's hair with bare hands. Cover water catchment systems when ashfall is expected, and use the overlooks the park keeps open rather than the ones it does not, because the closed ones are closed for reasons that are written into the ground itself. One more thing worth sitting with. The observatory noted that its monitoring network is still recovering from power and storm-related outages, and that several summit stations, including one of the tilt meters, remain offline because crews cannot safely reach them across the deep field of tephra southwest of the caldera. The eruption is burying the instruments that measure the eruption. That is not a crisis, and the network is largely restored, but I find it a strangely honest detail. The people forecasting this thing are working with a system that the volcano itself keeps damaging. 53 episodes, 19 months. A cone 150 feet taller than the rim used to be, a record that no eruption in recorded Hawaiian history has come close to, broken, and then extended 5 times over. A forecast method precise enough to name a range of days and imprecise enough to be beaten by 24 hours by a volcano that does not read the bulletins. Somewhere under Halemaʻumaʻu right now, magma is moving back into a reservoir that just emptied part of itself into the sky. The tilt meter is already counting, and when that number climbs back toward 10, the whole thing starts over. Subscribe and turn on the bell, because the next number to watch is the one that opens the window for episode 54, and I will bring it to you the day it appears.